So just a few comments on the SBDI4R package. As we speak, or during these weeks, the ALA4R package has been retired from CRAN, which is the common repository of packages, which is curated. So, and when you install following instructions SBDI4R, it assumes that it can download the ALA4R package from CRAN. So we will shortly add a comment how to install also the ALA4R from another repository, but that should be no major problem. As Deborah mentioned, I will show you very briefly the capabilities of the SBDI4R package with two examples, one from a monitoring dataset and one from an opportunistic dataset. And show briefly the commands. The idea is not to go through every code, but just to show what is possible to do with the package, and then you can follow the tutorial yourself. The first example, as mentioned, is based on the Swedish electrofishing registry from the SLU Aqua database. It has about 2.8 million observations starting in the 1950s. The first capability of the package then is to start browsing the data, what is available. And for this, we have developed this particular function that is not in the ALA4R or in the Gala yet, but maybe we'll move to that package as well. And for that, I will show you how you can create your filter. So the aim is to create a string text variable that stores pieces of the filters that you want to apply to your query. And you can store those in a variable. So this is my mirror environment, and I call the library SBDI4R. And the first thing that I do is call the pick filter function without any arguments. I can write directly the type of filter that I want to introduce, but if you don't specify anything, it will ask you, do you want to browse by resource, by species list, or by layers? And there is more documentation on what each will show you, but roughly the resource is the kind of data you want. The species list is if you want to filter by a defined list of species that could be conservation interest species and so on, or if you want to filter and to browse which kind of environmental layers or additional layers you have in SBDI, which is plenty of. We type resource, and then we get a next question. This is an interactive way of listing all the resources that we have. We first are presented with a list of institutions, and we can try, for this example, we want to start with institution 3. So we see that if we go through the list, the Swedish University of Agricultural Sciences is the institution number 3. We hit enter and we get another question. which is, do you want collections or data resources? There is a difference in how this data is presented, but for this, in this example, we know that we want the data resource 10, which is the Swedish electrofishing registry. So we type DR10, and that's it. We now have added a filter in our variable. We can continue if we want to add more filters, which will be added as AND statements in our query. Sorry, as OR statements. So it's keeps adding different sources. Or we can just hit enter, and we are presented with this string that is going to be passed as a part of the query. So we want to limit the search to only this data source. Let's try to go back to the presentation. Yeah, so then the variable filter query string will have a, as mentioned, a vector of different strings. We can add to that other parameters, like for example, if we want to filter by year, we concatenate the previous filter string with a particular syntaxes for how we add beginning and ending years in the range. There is lots of documentation on how you can specify this string on the SBDI APIs documentation that is in this link. But this is just for you to know that you can add in this vector multiple different kind of filters. And the next step is to search for the occurrences. So the function occurrence will retrieve the occurrences that matches your query. You should when you install and you go through the tutorial, you have to carefully read the first part where you are introduced to the SBDI configuration, the function, where you have to add a valid email and a download reason for your query. And you can search also. There are different download reasons, and there is documentation of that as well. Yeah, so you get a complete string. You just pass the filter query equal to your filter query string, and the data is downloaded into these other variables, XF. XF will come also with metadata, not only the occurrences. Therefore, when working with it, you have to specify that you want from this data that you downloaded, you have to specify the data. But just for you to know, you also have metadata that comes with the observations. And just straight from the package, you can directly produce some summaries with the function occurrence plot, which generates by default PDFs, where you have 1 page per species, and you can specify that how you see the observation locations, and if you want them to highlight different types of assertions, what kind of potential problems each data point has. So you have a first look on on how the data looks like. And now I've been browsing in the wrong file. Yeah. But there are many options on how you can plot this data. The occurrence data will come with columns for the coordinates, which as standard comes in the coordinate system WGS84, which is standard. And for example, you can use the package leaflets to produce an interactive map and browse these data more interactive and follow a particular location and see how many points you have for this particular area. Yeah, and the possibilities are not endless, but very wide. You can produce many different types of maps and plots. You can also explore quickly make a temporal summary by just quickly making a histogram of the column year, for example, and see whether your data is biased through time, or if there is a decreasing, like in this example, a decreasing trend in the number of observations, how many records we have for each year. And this is just straight with the data as we download it. We can look also at the different species, if we have any particular species that is more represented than others. And you can do these by the common name or by the scientific name, and quickly produce a table with the frequencies of observation, the number of records for each species. Here I am just presenting this 6 first, but it's a long list of species. And you can, of course, download that as a CSV to share with other colleagues that don't have access to R or don't know how to. Yeah, a little bit more advanced analysis could be a spatial biodiversity analysis, where you do both space and different taxa. And the SBDI4R package provides you with both polygons for standard polygons for Sweden, the territory, the municipalities, and so on. And with standard grids, it's a 5, 10, and 50 kilometers grids over Sweden, which are the same that are used on the web portal, in case you want to match that. And here we show quickly in the tutorial how you can overlap your observations to that grid set, so you can do summaries by using that grid. This package uses it has now migrated to SF, which is a package in R, which is the most common package for spatial analysis. So make sure that you install the latest version from GitHub that is migrated to SF in order to be able to follow these examples. Otherwise, you will get warnings on mismatch of data, because the previous version of the package had all the data in another format. Yeah, so you can overlap and make an intersect of the grids and the observations, transforming the observations as a spatial layer. And from these, you can also plot. The result of this intersection will be a list. If you're familiar with R, if the data could be stored in different formats, and list is one of those where each element has another data set or vector, or could have different formats of data within each element. In this case, each element of the list will be a data frame with the full set of observations, and you can apply some statistics to each of those grid sets quite easily with the function apply, list apply. And you can restrict that to only those grid cells that are not empty. That's why in the previous, the last thing that we do is the which not empty to make it more efficient, and only work with those elements in the grid set. And finally, you can plot over Sweden this grid set with a standard color gradient. I keep browsing wrong. Yeah, so it's pretty easy to come to a result like this, where we show both the Swedish borders and the grid set. We can now ask, what is the richness, for example, across latitudinal gradient? And using, here we wanted to show how you can use, for example, the tidyverse syntaxes, which has been now adopted in the more or less in the new release of R, which uses these pipes mainly to show more easily what steps are you doing. And here we show that you can round the coordinates to make groups. Then you group by those coordinates and select species, and do some filters and calculations to reorganize data so that you can have a figure where you plot the latitude versus how many species you have on each of those categories of latitude. This is now disregarding the grid, working again with the raw data. And again, another way of we try in the tutorial to use different syntaxes for making plots and maps, because there are different different ways of doing everything. Some people like working with the library ggplot2, which is pretty standard for figures. Some other people like the base functions. So we try to mix those so that you know that it's not linked to any of those syntaxes. So that was with the monitoring dataset. You can pretty easily transform these observations into different formats to produce summaries very quickly. On the next example, we will go a little bit farther on how you can transform this data and start cleaning and grouping the observations in another way. And for this, we will use we will explore the opportunistic data on dragonflies. Again, we start with the name searching. The SBDI4R package has a set of functions to make taxonomic searches. For example, you can search by full text or Donata. Give me everything that is available that matches the word Ordonata, which is the order for dragonflies. And in this case, we're interested in those observations from the Swedish Citizen Science observation portal, which is our portal. A quick search will, so yeah, when we run a function, we will get the URL that we're using to get that query. So if we use this URL in a browser, we will get the same results, just for you to check sometimes you want to debug some of your code. And in this case, we're making a query for Ordonata, and we're filtering by taxon. And what we get is we see that there are many things that match the word Ordonata. Some of them, I guess, are viruses because they are called virus. There are no occurrences for those, but if we anyway want to remove those from our search, we want to restrict the search to something that is more appropriate for the order Ordonata. So we can see, we can use the function SBDI fields to see which is the filter query string, the keyword that will filter for a specific order in this case. So I can show you in RStudio as well, how do we work with these search fields. So let's make this one bigger. If we write, I can clean this so we start fresh. So if we use this function SBDI fields and write, for example, general to start browsing from the first level, there is an error. Of course, that's what happens in live when one tries to show something in live. That should be specified. Okay, if I restart maybe session. Yeah. So we're presented with a list of names for these search keywords that we can use in our query. We have used, for example, data resource in the previous search using the peak filter, but we know that we can use all of these ones, and you even know if it is indexed. The indexation is a process that something that is done in the database to make searches faster, and you know that, yeah, you're presented with which of these filters are indexed and what's the data type that you are expecting from the search. And we see that most of the or many keywords have the _s at the end because in a general search, yeah, you use this search keyword. that's not very explanatory, but you have to use these keywords, and we will see how what else do you use. So we make a search with order S colon ordinata, because we knew that that was how we wanted to look for, and we restrict the search to a page size of 10, so we can just skim what is coming out from list. And what is coming out is list with with taxons that are ranked species, so are defined by at the species level, and these first taxons have no occurrences, although they are registered. But at the bottom of this list, we will surely find some other taxa that has some more observations. And all of these are only species within the order Ordinata. Now we can download the whole taxonomic data for this order Ordinata, and that we do with tax info download, the function that will download the whole taxonomic tree for Ordinata, everything that is within Ordinata, including subspecies or definitions lower than species, and genus and orders, and so on. And we can save that for later use if we want to make a specific search. But we can, for example, restrict after we download the data. We can restrict the species to anything that is on the rank is equal to species, and the genus is not empty. And in that way, we filter out everything that is, for example, hybrid species or any other sub taxa that we don't want, and also, for example, the taxa that matches only the genus. We can also apply some filters. In this case, I won't show it, but in the same way, we make a filter for the data resource DR5, which is art tolerance data from the institution SLU. And we apply also a time restriction to search only within a period. And we also want to apply to search a spatial filter. So in this case, we want to send a string that contains a polygon or a geometry within which the database will constrain the search. And for this, we have to do a couple of steps. These strings comes, we have to send it in a particular format, which is the well-known text. It's a format in which one of the formats in which geometries can be passed. And we can do that using, for example, one of the layers that comes with the SBDI package. So we get the data set suite from the package SBDI, and in that data set we have, again, it's a list with many layers. One of those layers or elements is the counties, and we want to select from this list, from the layer counties, the column name for and we want to match all these counties that we know are what define Jättaland, which is a no official region. We just want to gather these counties. So we get an index for those, and we just pick those and save those as Götaland. And now we have to construct a WKT string, and it's pretty easy. We just transform that that polygon into a particular coordinate reference systems, which is this number matches WGS84, which is the standard that has to be passed. In this case, the data is already in WGS84, but we show this in case you have another data that you want to transform as well into. You don't have to forget this step to transform the data, otherwise the search will return nothing. And then we don't want to pass many polygons within the WKT, because the string cannot be too long. We have to constrain the number of characters. So we make a union of all the polygons, and then to make it even shorter, we make a convex hull around that simplifies the function without leaving anything outside. And then this is a very important step, not to forget, the APIs. Right now, I mean, I don't know if that will change or not, but right now it only takes, even if you send one polygon, it takes the WKTs in a format that is a multi-polygon. So you have to cast or transform that polygon into what is called a multi-polygon. There are lots of detail here. You can investigate more what is a polygon, what is a multi-polygon, but don't forget to make this particular step. And then quite easy, SD as text, and that will give you a string. That is what you will have to add to the filter query. Just to summarize, this is the string. The text that will be passed is too long to in the screen, but you have a series of coordinates describing each node in the polygon, and we have the counties, the other united or dissolved polygon that is the outer shell of Götaland, and then the search polygon, which is the convex hull, to make it even a shorter string to pass to the URL. And again, we download the observations, the occurrences from data. So we specify taxon, order ordinata, and now pay attention that we write order, not order S. The order S was when we did a general search. In this case, we are downloading occurrences, so we have to check for the keywords for occurrences, and that can we also show you in RStudio how it looks like. With the same SBDI fields, instead of general, we look for occurrence, and then you will get the keywords, which are many more, to filter the occurrences. As you see, the list is much longer, and if you look in this one, the order, the keyword that matches order will not have these _s. These details are need to be remember when you write these filters, these keywords by yourself.
Yeah, then you add the filter query, which is
adds the times and the spatial, the time, but the spatial filter has this particular place, which is the WKT argument in the function occurrence. And then you have extra, if you want to add extra columns. All this is documented in the package documentation, but just wanted to show how the capabilities of these functions. So you can add columns to the standard set of columns that comes with the data. Yeah, so then you get again a set of observations, occurrences. We go further in this example and use the package birds to summarize sampling effort and check whether the data is fit for use. We will use a grid over 25 kilometers to do this summary in this example. Also, the birds package was on-prem, but not any longer. Some changes are being done. Make sure you install it from GitHub. There is documentation there, and you can also find in GitHub the documentation on other functions in the package. But the basics of these other packages that you organize data, saying which are whatever data format you get data from. You say which column is defining the rank, and you want a specific rank to be preserved, not the other ones. You want to filter out all the other ones. You define which columns are defining your visits. So we will collect all the occurrences by collector and by locality to create visits, groups of occurrences that most likely match the same event of observation. And this can be defined in many different ways, even using the grid instead of the defined locality. Then you define which columns of this data set will define you the time, and in this case, you either use a complete date column or the year, month, and day, and then they will merge them, and which one are the coordinate columns. This will then will produce will organize and produce a condensed data set, which you can intersect with the data. In this case, we will produce also a grid set. We will get from the SBDI4R package the 25 kilometer resolution grid set, and we will intersect with Gotland, Jätteland. So that is the other polygon that we created. So we will only want those grid cells that matches, that overlap the Jätteland polygon. And we will use only those grid cells to summarize the data. So OB is the organized data, and we will summarize that. And the summarized data set will have different elements where you have spatial, temporal, and grid cell wise summaries of the data. You can explore more on what that means, but basically with a quickly exploring the spatial temporal summary, you can plot over this grid cell quickly how does data vary over time and space. summarized by, for example, number of observations, which is one of the variables that comes with the summary in this package. So in a few lines of code, you can get these plots showing time series, how this opportunistic data varies. You can also make other kind of plots directly querying this spatial layer, in this case using, again, ggplots, but you can explore the number of visits using the column that comes in the summaries, the number of visits or the number of species, and you can contrast directly what's the distribution of the number of visits, most likely increasing in nearby cities like Malmö or Lund. Here maybe it's the university having a high impact, but the number of species has another distribution. Again, this is not corrected data, so that doesn't mean that the number of species is lower in this other area, but at least we have a first visual representation of where the data has been collected. You can also explore quickly the temporal dimension, for which you will have a daily base summary on the, so if you query from the SB element that you created, the temporal element, you will get in the data set that is format XTS, is a particular format for data time series, and you will have the number of observations, number of visits, and number of species per day, and you can quickly query a particular range or a month, and you can use the package XTS to make some quickly plots also on the temporal variation on the number of observations and number of visits over time within the whole data set. Then you can explore quickly these some species summaries. If you run the function species summary on the SB, you will have summarized number of cells, observations, and visits for each species that has been observed in this data set. And using, again, the library dplyr, you can make some transformations and some other calculations on focal species. For example, we want to focus on these two species and create some summaries for only these two species, and look in this case at the number of visits where the species is reported relative to the total number of visits. And this is just the code to show you that in a few lines we can produce what is a standardized set of presenting the relative number of visits with observations for each species. This is, again, not correcting for missing observations or big biases in the observations, but at least we know if there is any trend among the total number of observations, the proportion of these two species within the whole set. And that was it with the two examples. You can browse more in detail and follow the code yourself. But as Deborah mentioned, your collaboration is appreciated. And there are many ways in which you can contribute to these functions. One would be, of course, sending your request via the support center, as Matthias showed, but also submitting either issues on the GitHub repositories with your ideas, or presenting the bugs that you have encountered. You will certainly find some bugs. Or you can contribute also by forking the code, so making your own copy, transforming, adding functions as you please, and then submitting a pull request in which, if everything works, could be merged into the original repository. And the repositories that you can contribute with are the action middleware, in case you want to add some package or you see something that could be improved. The actual SBDI4R package, again, this is not going to be developed further as is, but has to be adapted to the Gala package that is already in front. But anyway, if you have an idea for a cool function that you want to use to summarize in a particular way that you think is going to be useful for other people, you can add it and submit your pull request to that package anyway. And those in charge of adapting can take that with them into the next version. The general analysis workflow, which is a web page, is a book down page, but you can also correct some typos if you want, or adding sources of information to that. And this whole R tools tutorial, you can also contribute by making changes into that tutorial. Just a short comment on this tutorial. The presentation that you saw, it has been migrated to SF, to this spatial format, but the tutorial is not yet adapted, so you may find some differences, and we will shortly bring those changes into the tutorial.